Uh, Good afternoon. Now we are with some clauses that are related with your LD and all. So now we can have, you can see this. So we are at simple support and at points of inflection, positive moment, tension reinforcement shall limited to a diameter such that LD. Why we are providing development length? If we are not providing development length and if we curtail any bar, suppose we have curtail, we are according to bending moment, we have to curtail bar at this point, and if we will curtail, then we have stress concentration will occur over there, stress concentration, and due to this we are going to be stress directly transferred to the concrete and concrete may crack. And instead of this, we are going to provide that is development length. And through that, this development length, we are going to transfer this stress to the slab. And due to development length, we are going to avoid stress concentration in the bar. Now these values are given does not exceed 26.2.1. So now that we will see, we have that value LD, we can say does not exceed. So positive moment tension reinforcement shall be limited to a diameter such that LD calculated for FD by does not exceed, means LD should be less than or equal to M1 by V plus L naught. This LD calculated. So now we have M1 by V plus L naught. So these values are given. I will not go in detail. L naught that is given. So is limited to the effective depth of the member or 12 phi. And phi is the diameter. We will not go in detail with this. We have seen in the class. The value of M1 by V in the above expression may be increased by 30% when the ends of the reinforcement are confined by a compressive action. Means this value we have less than or equal to 1.3 M1 by V plus L naught. So that is our value. So LD, we are going to calculate, we have that formula phi sigma LD, we have phi sigma S upon 4 tau BD. And that is bond stress tau B. So now we have minimum distance between individual bars. The following shall apply for spacing of bars. So between two bars, so they have given three criteria. One, that is the diameter of the bar, if the diameter are equal. The diameter of the bar, if the diameter, all diameters are equal, then it will be diameter of the bar. The diameter of the longer bar are unequal, means one is 20, another is 25. Then we have 25. It should be 5 mm more than the nominal maximum size of course aggregate. So we have these three criteria and we have to take greatest of the three. Then we have maximum distance between bars in tension. And that unless the calculation of crack width shows that greater spacing is acceptable, the following rule shall be applied. So now in beams, you can see the horizontal distance between parallel reinforcement bars or groups near the tension face depends on the amount of redistribution carried out in analysis and characteristic strength of reinforcement. So in slabs, so actually table is given. If we will go to table 15, and in that table 15 and 15A, these values are given. And from that, we can decide the minimum distance between the bars. Then in case of slab, for main reinforcement, this value is 300 mm. That is 3 times the effective depth or 300 mm, whichever is smaller one. Then for transverse reinforcement or distribution reinforcement, we have this as 5 times the effective depth or 450 mm, whichever is less. Nominal cover. So the nominal cover is the design depth. So we know that is from face to the center of from face to the bottom, you can say. So depth of concrete cover to all steel reinforcement, including links. It is the dimension used in design and indicated in the drawings. It shall not be less than the diameter of the bar. This is one given. The nominal cover to meet durability requirement. So that is given in table 16. We can refer, and from that we can see actually that 16A also is given. So not 15A. So that is only 15. Here we have 16 or 16A. Now, however, for a longitudinal reinforcement in column, this in any case value should not be less than 40 mm. Then in the case of columns of minimum dimension of 200 mm or under, whose reinforcement bar do not exceed 12 mm, a nominal cover is 25 mm. But our column are rarely less than 200. So we have that value 40 mm. And for footing, we have this value as 50 mm. Generally, we are taking effective cover, that is for slab 20 mm, for beams 40 mm, for columns we are taking 50, and for footing we are taking 60. So these are given nominal cover, that is here they have mentioned design depth of concrete cover to all reinforcement, means this is given clear cover. We have this as clear cover. Then we have that is requirements of reinforcement for structural members. So tension reinforcement minimum, we have AS upon BD equal to 0.85 upon Fy, and this is generally used in case of beams and in case of footings. In case of beams and footings, we have to use this. So actually you may have used or not, you just check it. If we have taken 0.12 or 0.15, at least in orals, we have to say this will be minimum area of tension reinforcement for beams and footing. And for maximum reinforcement, we have value given 0.04 BD. So these are the clauses which are related with your distance between the bars. So now we will stop here only. So remaining part we will see in the next video. Thank you.